In the previous lecture, we discussed about the angular displacement and angular velocity. In that lecture, we will first discuss about what is angular acceleration. By the definition of angular acceleration, we found the angular acceleration of an object moving in a circle or rotating about an axis is the ratio of the object's change in angular velocity, which we represent as del omega, to the time del of t required for that change. That means when an object is rotating through a circular path about an fixed axis, then this rotating path or circular path, when it rotates, there is a change in angular velocity. There might be a change in angular velocity. So if our change in angular velocity of del of omega and the time del of t required for the change and the change required, the required time to change, if the required time of change is del of t, then we can represent this angular acceleration. We represent angular acceleration as alpha. Alpha will be equals to del of omega by del of t, and the unit of this alpha is radian per second square. This is the unit of the our angular acceleration. So in the previous video, we are making some relationship between the angular velocity and the linear velocity. In the same in the same manner, we will make some relationship between angular acceleration and vector and linear acceleration. So the relationship between this angular this angular acceleration and linear acceleration is, if we represent angular acceleration as alpha and we represent linear acceleration of a, and the radius vector is r, so we can write a equals to alpha r. A equals to alpha r, or in the vector form we can write a equals to alpha cross r. We can represent this as a equals to alpha cross r. This is the cross product of these two vector, and so that so we will get another vector in which is acceleration. Now coming to the second part, we derive some equation in our linear motion chapter. Linear motions chapter. In our linear motion chapter, we derive some equation. One is like for the displacement or distance, we represent s is equals to vt, while s is the distance. We represent distance as s, v is the velocity, and t is the time. When we multiply the velocity with time, then we will find out the distance of the particle. So this is our formula number one, and we have to remember this v is uniform velocity. In that case, the v is uniform velocity. The second equation is v equals to v naught plus 80. V equals to v naught plus 80, where v is the final velocity. If you want to find out any final velocity of a object, then we have to know the initial velocity of that object. The v naught represent the initial velocity, a is the acceleration, t is the time. So after t second, what will be the velocity of that body? By the help of this linear motion equation, we will find out v equals to v naught plus 80. This is our second equation. Our third equation is s equals to v naught t plus half of 80 square. In this equation, if we know the time t and the initial velocity v naught and the acceleration of that moving particle, then we can find out after t second what will be the displacement of that body. What will be the displacement of that body, or what distance it cover after t second. So this is our third equation, and the fourth equation is v square equals to v naught square plus 2as. So in that case, if I know the but the distance it traveled, if we know the acceleration of that body, if I know the initial velocity of that body, I can find out the final velocity of that body by the help of this equation. Here s represents the displacement, a represents our acceleration, and v naught is the initial velocity and v is the final velocity. And the fifth one is s equals to v plus v naught divided by 2 into t. Here v is our final velocity and v naught is our initial velocity, and t is the time. So by the help of this equation, if I know the value of initial velocity and final velocity, and we can find out after t second how what will be the distance it will travel, the body will travel. So these are the five equation we are derived in our linear motion chapter. If you want to learn more about this five equation, you will see our video in our linear motion uh, uh, in linear motion chapter. So this is our five equation. By the help of this equation, we can derive the circular motions equation. Circular motion equation. Here, in that case, we will replace as the linear displacement or linear distance with theta. We will uh, replace v with omega, which is our angular velocity. We'll replace v naught with omega naught. We will replace a with alpha. Here alpha will be our alpha is the uh, angular acceleration, while a is the linear acceleration. And we will this is the fourth term we will replace with this as v naught and a. So if I replace this as v naught and a, I will get, for the first equation I will get theta equals to omega t. For the second equation I will get omega equals to omega naught plus alpha t. The third equation is theta equals to omega naught t plus half of alpha t square. The fourth equation will be omega square equals to omega naught square plus 2 alpha theta. 2 alpha theta. And the fifth equation will be theta equals to half of omega naught plus omega into t. So if I replace this as a v naught and a with this theta, omega naught and alpha, I will get this five equation, and this is the circular motion equations. And here by the help of this equation we can find out the angular displacement after t second. We can find out the angular velocity after t second with the initial velocity given, and angular acceleration is given. We can find out the theta by another two equation, or the angular displacement by another two equation. One is omega naught t plus half of alpha t square, and the second one is omega naught plus omega into t. And we can find out also the final velocity of omega square by this equation. So these five equations are very important to remember and solve the mathematical problem about circular motion. There are another terms we have to learn about the circular motion is, this is known as centripetal force, which is known as centripetal acceleration. Centripetal acceleration. So what is centripetal acceleration? Centripetal acceleration is an object moving in a circular path. An object moving in a circular path of radius r with a constant speed v. Suppose this is moving with a constant speed v, has an acceleration called centripetal acceleration. The acceleration is directed toward the center of the circle. So when a body is moving in a circular path of radius r, a then a acceleration is happen towards the center of this circle, and this is known as centripetal acceleration. So how can we find out this centripetal acceleration? We know for force, we know the formula for C is F is equals to m of a. We will discuss this force F equals to ma in our next lectures. First of all, we have to you just know the fact that if we want to find out the force, we will have to know two terms. One is what is the mass of this object, and the acceleration it is moving. So if I know these 2 points, then I can find out the force of that object. So similarly, when we suppose this is an string and this is a stone, and this is my finger, I am rotating this stone with the help of my finger, and I applied some force to revolving it. When it revolves, after some time, I will found a force happen towards my finger. I will found some force happen towards my finger. Why it is happen? Because an centripetal acceleration is occurred towards the center, and the center is my finger. So there are a centripetal there is a centripetal acceleration. For that case, I am finding a force happen to my finger. This is known as centripetal acceleration, and it acted towards the center. And we have to remember the formula of finding centripetal acceleration. If I represent the centripetal acceleration of a of c, then the formula of A of C is equals to V square by R, or omega square R. V square by R, or omega square R. So if I know the linear velocity, I can find out the centripetal acceleration. Perhaps if I know the angular velocity, I can also find out the centripetal acceleration. This is two formula for the centripetal acceleration. Next part, which we have to solve some problem. So this problem says that an electric fan revolves 1500 times per minute. The fan stops revolving after 4 minutes from the time of switching of the fan. What is the angular acceleration of the fan? And the second part of the question is, how many times will the fan revolve before coming to rest? So first of all, we have to remember, we have to determine what are the information we are given. First information is the it the fan revolves 1500 times per minute. So from that we can find out our initial angular velocity, which is that it revolves 5000 1500 times, and we know that as it revolves in circular motion, it it revolves 2 pi, and the time period of this revolution is 1 minute. So 1 minute means 60 seconds. So if I calculate this thing, I will find out like it will be equals to 50 pi, and the unit of this of the angular velocity is radian per second. Here our time period t is equals to t means when the fan stops revolving. The fan stops revolving after 4 minutes from the time of switching off. So our when I switch off the fan, it revolves 4 minutes from that time. So our time t is given equals to 4 seconds, and this time is our time period, capital T. And another information, so what we have to find out? First of all, we have to find out the angular acceleration of the fan. So for our first question, we know the formula is we discuss a formula which is omega equals to omega naught plus alpha t. Here this omega naught equals to, we find out this omega naught, the or initial angular velocity is 50 pi, and after 4 minutes, this is not 4 seconds, this is 4 minutes. After 4 minutes, or you can say that 4 minutes means 4 into 60 second or 240 second. So after 4 minutes, the fan is stops revolving. When we switch off the fan after 4 minutes, it stops revolving. So for that case, our omega will be 0. So our final velocity, final angular velocity will be 0. So our omega will be 0, and we know that omega naught equals to 50 pi, and we have to find out alpha, and now t equals to 240. So from that we can find out alpha equals to minus 50 by 50 pi by 240, which is equals to minus of 0.654, and the unit of this angular velocity, angular acceleration is radian per second square. So we solve the first part of our question. Now coming to the second part, how many times will the fan revolve before coming to rest? So let it revolves n times. It revolves n times before coming to rest. Before coming to rest. Before coming to rest, it revolves n times. So we have to find out the n. So for finding n, first of all, we have, for finding n, we have to find out not n. Sorry, this is not n. That will be, let it revolves theta times before changing to rest. Theta times before changing to rest, because revolvation is one of kind of like, we can say that it is one kind of, now coming to the second part of our question, let it revolves n times before coming to the rest, before coming to rest. So we have to find out this value of n, and we know for the n times displacement of angular displacement of n times equals to theta equals to angular displacement is theta equals to 2 pi n. So for n we can write n equals to theta by 2 pi. Now we have to find out the theta first. So for finding out theta, we know an equation is omega plus omega naught by 2 into t. Here we know the final angular angular velocity is 0, and our initial angular velocity is 50 pi, and the time equals to 240 seconds. So if I calculate whole of this thing, we will find out the value is equals to 6000 pi, and we know the unit of angular displacement is radian. The unit of angular displacement is radian. So we find out the theta. So we have to find out, now we have to find out n. So we can write n equals to, instead of theta we will write 6000 pi and divide by 2 pi. So if we cutting down all of this thing, we will find out 3000 revolution. So it will revolve 3000 times before coming to the rest after switching the fan. So this is our two question. This is the two part of our question we just solved. Now coming to the next one. The next question is, the electron of hydrogen atom is revolving around the nucleus in a circular path of radius 5.2 into 10 to the power minus 11 meter. with the velocity of 2.2 into 10 to the power 6 meter per second. We have to calculate the centripetal acceleration of the electron. For centripetal acceleration, we know AC equals to V square by R or omega square R. Now we have to determine what information we are given. So first of all, we are given that the radius of the circular path is 5.2 into 10 to the power minus 11 meter, and the velocity, and this is the and from the unit of this velocity we determine that this is our linear velocity. So the velocity v is 2.2 into 10 to the power 6 meter per second. So we have to now find out what is the centripetal acceleration. For centripetal acceleration, we will use this formula because this formula use the linear velocity. So for that, we will use v square by r. Here the value of v square equal v is 5.2 into 10 to the power minus 11 whole square, and the value of r is sorry, this is not the value of v. The value of v is 2.2 into 10 to the power 6 meter per second, and the value of r is 5.2 into 10 inverse 11 meter. It is meter per second, this is meter. So if I calculate whole of this thing, I'll find out the answer is 9.31 into 10 to the power 22 meter per second square. So it is our centripetal acceleration for the electron of hydrogen atom. So that's all for today's video. We solved some problem of circular motion in our previous lectures. We solved some problem about projectile motion, horizontal projectile motions and projectile motions, and in that chapter we are discussing two-dimensional motions. So this is one of the important chapter of physics. So we have to understand all of the concept of two-dimensional motion. So if you like this, if you love our content, please like this video and do subscribe to our channel. Thank you.